From the dawn of time, humans have gazed up at the cosmos in awe and wonder. The twinkling stars, seemingly eternal and unchanging, have captivated our imaginations for millennia. But the universe is a dynamic and ever-evolving place, and even stars have a life cycle. They're born, they shine, and eventually they die. And some stars, well, they don't just fade away quietly. They go out with a bang, a cosmic explosion of unimaginable power, a supernova. These cataclysmic events are among the most energetic and luminous phenomena in the universe. Prepare to be amazed by the power and beauty of the universe's grand finale, the supernova. To understand the awe-inspiring power of a supernova, we must first journey into the heart of a star. Stars, as you may know, are not just twinkling points of light, they are gigantic luminous spheres of plasma, held together by their own gravity. Deep within their cores, a cosmic dance of nuclear fusion is taking place, converting hydrogen into helium and releasing the energy that makes stars shine. This process of nuclear fusion is a delicate balancing act. The outward pressure generated by the energy released in the core pushes against the inward pull of gravity. For most of a star's life, these forces remain in equilibrium, allowing it to burn steadily for millions, even billions of years. But this equilibrium can't last forever. Eventually, a star like our Sun will exhaust the hydrogen fuel in its core. As the core contracts and heats up, it begins to fuse helium into heavier elements like carbon and oxygen. This process releases even more energy, causing the star to swell into a red giant, engulfing its inner planets. But even this stage is temporary. For stars much more massive than our Sun, the story takes a more dramatic turn. These stellar giants have enough mass to fuse elements all the way up to iron in their cores. But iron is the end of the line. Fusing iron actually consumes energy rather than releasing it. With the core no longer producing outward pressure, gravity takes over, and the core collapses in on itself in a fraction of a second. This rapid collapse triggers a shock wave that rips through the star, tearing it apart in a cataclysmic explosion, a core collapse supernova. Whether it's the core collapse of a massive star, or the thermonuclear detonation of a white dwarf, supernovas are the universe's way of reminding us that even in death, there is incredible beauty, power, and the potential for new beginnings. In the aftermath of a supernova, the cosmos is left forever changed. The explosion blasts the star's outer layers into space at incredible speeds, scattering the elements forged in its fiery furnace far and wide. This ejected material, enriched with heavy elements, forms a breathtaking nebula, a cosmic tapestry of gas and dust, illuminated by the fading glow of the supernova. These supernova remnants, as they are called, are not merely beautiful spectacles, they are cosmic recycling plants. The scattered elements born from the heart of a dying star become the building blocks for new generations of stars, planets, and even life itself. But the heart of the exploded star, the core that once powered its brilliance, undergoes an even more profound transformation. For stars like our Sun, the core collapses into a white dwarf, a dense Earth-sized object that will slowly cool and fade over billions of years. However, for more massive stars, the core's fate is far more extreme. The immense gravity of the collapsing core overwhelms even the forces between atoms, crushing the core down into an object of unimaginable density, a neutron star. Neutron stars are just a few miles across, but they pack the mass of our Sun into that tiny space. But for the most massive stars, even the formation of a neutron star is not the end. If the core is massive enough, its own gravity will continue to crush it down, collapsing it into a black hole. Throughout history, humans have witnessed the awe-inspiring power of supernovas, even before we fully understood their nature. One such event, in the year 1054 AD, captivated skywatchers around the world. Chinese astronomers recorded the appearance of a guest star in the constellation Taurus, a star so bright that it was visible in broad daylight for nearly a month. This celestial visitor, which we now know as SN 1054, gradually faded from view, but its legacy lives on. Today we can observe the remnants of this ancient supernova, a cloud of expanding gas and dust known as the Crab Nebula. Centuries later, in 1987, astronomers witnessed another spectacular supernova, this time in the Large Magellanic Cloud, a dwarf galaxy orbiting our own Milky Way. SN 1987A, as it came to be known, was the closest and brightest supernova observed in centuries, providing astronomers with an unprecedented opportunity to study these events in detail. The observations of SN 1987A confirmed many of our theories about supernovas and their remnants. These observed supernovas provide us with valuable clues about the life and death of stars, the origins of the elements, and the vastness and wonder of our universe. As we gaze out into the cosmos, we know that somewhere at this very moment, stars are reaching the end of their lives, preparing for their grand finale. And while we can't predict exactly when and where the next supernova will occur, there is one star in particular that has captured the attention of astronomers and the public alike: Betelgeuse. Betelgeuse, a red supergiant star in the constellation Orion, is a true behemoth. If it were placed at the center of our solar system, it would extend beyond the orbit of Jupiter. Betelgeuse is nearing the end of its life, and astronomers believe it could explode as a supernova any time within the next 100,000 years. Now, 100,000 years may seem like an eternity, but in astronomical terms, it's a mere blink of an eye. And while we don't know exactly when Betelgeuse will meet its fiery demise, its eventual explosion promises to be a truly spectacular event. Imagine a star, once a faint red dot in the night sky, suddenly becoming as bright as the full moon, visible even during the day. For weeks or even months, Betelgeuse's supernova would light up the night sky, casting eerie shadows and captivating skywatchers around the world. But Betelgeuse's supernova would be more than just a spectacular light show. It would be a scientific bonanza, providing astronomers with an unprecedented opportunity to study the death of a nearby star in detail. So, while we wait for Betelgeuse's grand finale, let us marvel at the vastness and wonder of the cosmos, where even in death stars continue to inspire and amaze us. Supernovas are more than just spectacular events. They are essential to the very fabric of our universe. These cosmic explosions play a crucial role in the cosmic cycle of life and death, shaping the galaxies we live in and seeding the universe with the elements necessary for life. As we've seen, supernovas are responsible for creating the heavy elements that make up our world and our very bodies. The carbon in our cells, the oxygen we breathe, the iron in our blood, all were forged in the hearts of dying stars and scattered across the cosmos in supernova explosions. Without supernovas, the universe would be a very different place. It would consist primarily of hydrogen and helium, the lightest elements, with no planets, no life, and none of the complexity we see around us. But supernovas do more than just create the elements. They also help to distribute them throughout the universe. The shock waves from these explosions can trigger the formation of new stars and planetary systems, seeding them with the ingredients necessary for life. In a sense, we are all children of supernovas, our very existence inextricably linked to these cosmic events. And just as supernovas enrich the universe with heavy elements, they also provide us with valuable tools for understanding the cosmos. By studying the light from distant supernovas, astronomers can measure the expansion rate of the universe and probe the nature of dark energy, the mysterious force that is accelerating the expansion. Type Ia supernovas in particular are incredibly useful for these measurements. Supernovas, once thought to be destructive events, have become essential tools for probing the deepest mysteries of the cosmos. From the ashes of stellar death springs forth the very essence of life. The elements forged in the hearts of these dying stars, scattered across the cosmos in a blaze of glory, become the building blocks of planets, of life, of us. Supernovas, those seemingly destructive events, are in fact essential to the grand cosmic cycle of creation and renewal. They remind us that the universe is not static, but rather a dynamic, ever-evolving tapestry woven from the threads of stellar evolution. So, as we conclude our exploration of these celestial wonders, let us carry with us a sense of awe and wonder at the intricate workings of the cosmos, where even in death, stars shine on, their legacy etched in the very fabric of our being.